Hello friends, I am Sourabh Jain, a student of IAPS derive Indore, currently pursuing MTech in Information Technology. Today, I am going to explain you the working of merge sort along with an example and will derive the complexity equation of merge sort. So let us begin. The main thing we're gonna do here is we're gonna merge two sorted array to get another sorted array. The key to merge sort is the same, merging two sorted lists into one. For example, if we have two sorted arrays like L1 and L2 mentioned here, L1 is a sorted array and L2 is another sorted array. If we merge them using a special logic, then we get a big sorted array. Merge sort uses divide and conquer method to sort an array. Merge sort divides up the sorted list until there is still one element left and then sorts the divided part back together in pairs. For example, if you have an unsorted array and we need to sort this unsorted array to get a sorted array like this, the procedure we are going to follow here is we will divide the array into two equal halves. Equal when there are even elements in the array, but here we have odd number of elements, so one of the half will have one more element than the other half. If we are somehow able to sort these two subarrays, then we can use some approach to merge these sorted arrays to get the main sorted array. Now we are going to assign names to these two sorted arrays as x and y. We also have a resulted array in which we want the sorted array. We here have three pointers, one pointing to the initial element of x, one pointing to the initial element of y, and one pointing to the initial element of the resulted sorted array. Now what we are going to do here is we are going to compare the two elements 0 and 4. The smaller element will be copied in the resultant array here, and we will increment the pointer of y as well as the resultant array. Now we will compare the elements 4 and 9. The smaller element is 4. We will copy this element here and will increment the pointer of resultant array as well as x. Now we will compare 7 and 9. The smaller is copied here and increment the pointer of x and the resultant array. Similarly, we will copy 9 and increment the pointers. The smaller was 13. If we copied it, now increment the pointers. 17 here same, so we will take any of the one. We have taken x here and increment the pointer. Now we'll compare 22 and 17. We have copied 17 and incremented the pointer. We have found out 20 to be smaller, so we copied it and incremented the pointer. We have reached the end of y, so we'll do nothing. We will copy the remaining elements of x in the resulted array. That is, we will copy the 22 element and will increment the pointers of x and the resulted array. Now let us develop the merging algorithm. The algorithm has three parameters: low, mid, and high. Low having the initial value of the first sorted array, mid the last value of first sorted array, and high the last value of second sorted array. We will use here three variables h, I, and j. H having the value of low, I having the value of low, and j having the value of mid plus 1. We have a loop here while h is less than or equal to mid, that is while h traverses from the low to mid, that is all the elements of the first sorted array, and j traverses all the elements of the second sorted array. Now if a of h is less than or equal to a of j, that is we are comparing the two elements of the sorted array. Now if suppose the element from the first array is found to be smaller, then we will copy this element into the another temporary array and will increment this pointer. We have already seen this example. Else if it doesn't happen, then we will copy the second array's element into the temporary array and will increment its pointer. And every time we are incrementing the I pointer, this is because we are always incrementing the pointer of the resulted array, that is the temporary array here, that is bi. Now the thing is, if suppose one of the array is completely empty and the remaining array has some elements, like if h is greater than mid, this means that if the second array has some of the elements remaining, so we'll copy these elements for k equal to j to high, do b of I having the value of a of k for I incremented. We are copying the remaining values of the second array. If it doesn't happen, that means the first array has some elements and the second array is completely empty. That had happened in the example that we have mentioned. So in this case, we will copy the remaining elements in the array bi, and it will increment the pointer of I. Now when we have the temporary array b, we will copy this elements of this array in the main array A. Now we have learned how to merge to sorted arrays. Now let us get back to our example in which we were sorting an unsorted array. We have divided this array into two subarrays. Let us do the same for the third level too. Let us divide the subarrays into another subarrays and do this for the fourth level too. Now you have single elements 22, 4, 17, 7 for them. Keep in mind that every single element itself is sorted. Let us do this for the fifth level too to get 2 and 0 also. Now what we are going to do is we are going to treat this single elements itself as a sorted arrays, and we're going to merge this sorted arrays to get the main sorted array. For example, if we treat 2 and 0 as separate sorted arrays, then we can merge them down to get 0 and 2 as sorted. Similarly, we can merge 22 and 4 to get 422, 17 and 7 to get 7 and 17, 13 and 9 to get 9 and 13. Similarly, 17, 0 and 2 to get 0, 2 and 17. We can merge at the further level to get 422 merged with 7 and 17 to get this array, 13 and 9 merged with this 0, 2 and 70 to get this array, and after this we merge to another level to get the main sorted array. Now we get the sorted array, that is 0, 2, 4, 7, 9, 13, 17, 17 and 22. Now let us discuss the algorithm of this merge sort. An algorithm having two parameters, low and high. Now if the value of low is less than high, then get a middle element to partition this array. Then apply merge sort on the first half of the partition, that is the first subarray, and apply merge sort on the next partition, that is the second subarray. Now after you have applied the merge sort, you get the sorted array out of it. Then merge these two sorted array to get the main sorted array. Now let us derive the complexity of the merge sort. We take the assumption that n will be a power of 2. Now for n equal to 1, the time will be constant, as the time to merge sort n elements is equal to the time to merge sort n by 2 elements plus the time to merge two arrays each n by 2 elements. The time to merge two arrays each n by 2 elements is linear, that is n. Thus we have the two equations, t of 1 is equal to 1 and t of n is equal to 2t n of n by 2 plus 2 plus n. Now we solve this recursive relation. First we divide the second equation by n. We obtain this third equation by doing so. We get Tn by n is equal to T of n by 2 divided by n by 2 plus 1. Now we know that n is a power of 2, so we can write the fourth equation as T of n by 2 divided by n by 2 is equal to T of n by 4 divided by n by 4 plus 1. Similarly, we can form the fifth and the sixth equation as T of n by 4 divided by n by 4 is equal to T of n by 8 divided by n by 8 plus 1. And the sixth equation as T of n by 8 divided by n by 8 is equal to T of n by 16 divided by n by 16 plus 1. Now we have got these equations, and at the end we will get T of 2 divided by 2 is equal to T of 1 divided by 1 plus 1. Now we add the equations 3 through 8, that is 3 plus 4 plus 5 plus 6 plus 7 plus 8. The sum of the left hand sides will be equal to the sum of the right hand sides. So we obtain T of n by n plus T of n by 2 plus or divided by n by 2 plus T of n by 4 divided by n by 4 up to T of 2 by 2, and this in the right hand side. Here we get a term log n. Log n is the sum of ones in the right hand sides, that we can see here 1 1 1. We do not know this number of equations is not linear. It is n divided by 2 divided by 4 divided by 8, so it is log n. Now after crossing the equal terms, we get some of the equal terms like T of n by n here and T of n by 2. T of n by n has no equal term, but T of n by 2 divided by n by 2 has the equal term here, that is cancelled out. Similarly, T of n by 4 has the equal term here, which is cancelled out. After cancelling all the equal terms, we get the equation T of n by n is equal to T of 1 by 1 plus log n. Now we will transfer the n, we will multiply the n that side and get this equation T of n is equal to n plus n log n, which is nothing but O n log n. Hence the complexity of merge sort algorithm is O n log n. So with this I conclude my tutorial. I hope you like it. Thank you.